in traditional methods in the past, a designer would design a component in a CAD software, whether it's CATIA or another, and he would assess that design maybe via simulation and make an assessment whether the design is is suitable, maybe conferring with other colleagues, alter the design and go through the process again. And this can go back and forwards between design and simulation teams many times, with going through various iterations until they come up with the final design. That may not necessarily be the optimum design, but it's the design which they deem is a compromise and as best they can achieve in the given time. Whereas this new kind of performance-driven approach is where we use topological optimization at the concept level, where we produce a geometry which represents the full available design space. We freeze certain regions where the optimizer can't do any kind of optimization. We would set up what are the KPIs and let the optimization come up with a particular new design. And we can extend that by saying what are the kind of KPIs, whether it's stiffness, weight, cost, materials, and so forth. And we can add in manufacturing constraints, whether that is casting, forging, milling, additive manufacturing. So it won't come up with a design that is unmanufacturable for your current methods. And just to summarize then, so you've got, in the old approach, you might have different teams or different users, a designer and an analyst. They might be working in separate tools. They might be firing emails back and forwards via emails, sort of shared drives. And this can go back and forwards, and traceability can be an issue, and obviously time-consuming waiting for data to go back and forwards. So the hope is to use the platform in a kind of single interface, model-based solution with traceability to track the changes and make informed decisions all in one environment. So if we look at the actual workflow in terms of its stages, you would start off maybe with a design space that fully envelops where you could put the design, limited by surrounding components. Mesh the problem, provide various bolt constraints, contact, and so forth. And then run the topological optimization, where it will slowly remove material where it's not needed. And then provide tools to reconstruct the geometry. And that's pretty, that's that's a very valuable stage, to have tools to recreate the geometry. And then validate that simulation. We could come up with various design alternatives based on the different manufacturing methods. And we can compare them side by side, looking at the KPIs. And then come up with maybe the very final design for a final validation.